Hi guys, you're going to see my face for part of this video. Today we are going to look at 4.8, solving problems with trigonometry. And by solving problems, I'm not saying like solving your, maybe you have girl problems, or maybe you have problems getting a lawnmower started. No, we're going to be solving trig problems. Okay, two things you got to know: angle of elevation, depression. We talked about this in geometry if you had me. I'm going to talk about it again. Here's what I want you to think about. In a story problem, they're going to say the angle of elevation from the boat to the lighthouse, or the angle of depression from the lighthouse to the shore. And here's what they mean by that. So pretend like this arm right here is fixed. It's not going to move. Okay? This arm is stuck to my head. If I look down, it moves down with me. If I look up, it sticks up with me. Okay? Got it? Good. So let's say angle of elevation. What that means is I'm elevated. I'm in a good mood. I'm looking up. This angle that's formed here is my angle of elevation. Okay? Unless I'm depressed, I'm sad. This angle is my angle of depression. Not my armpit. Armpits are stinky. It's never your armpit. It's the one between my two arms. Okay? Think about that. Again, like if we're looking at Mount Rushmore, it's the angle that we're looking up, right to his eye, right into his eye. Okay? Your angle of depression is this angle from straight across down, not this one. That's the biggest mistake people make. Okay? This guy's going fishing. Little hook. Some fish. Okay. Angle. Let's use angle of elevation. Okay. You have a buoy. These are ridiculous. They're always with water. You have a buoy. That's a buoy, I guess. And to the top of Barnegat Bay, a lighthouse. Okay. Let me get this thing on that surface. So we have a lighthouse. It's shining light down, hitting the buoy. Okay. The lighthouse is 130 feet above the surface. The angle of elevation is 5 degrees. We're gonna draw a straight. Why don't I ever cheat more often on this stuff? A straight line. Okay. How far is that buoy to the lighthouse? Okay, so we have our opposite. We're looking for adjacent. So we set up our tan. Guys, remember examples are noteworthy. Tan of 5 degrees equals our opposite over our adjacent. So now first things first, we're going to have to multiply both sides by x. Get rid of those. So x tan of 5 equals 130. So we divide both sides by tan of 5. And we get our answer. 1 second. I need to go grab a calculator. I just realized my face is probably blocking this problem, so I'm gonna scroll down. I can't stop the face halfway through, so I'm gonna move back up here. X times tan 5 equals 130 over x times both sides by x. X, or divide by tan 5, and x equals 1,485.9 feet. That buoy is a long ways away. Actually, that's not even a mile. Not too bad. Okay. Gotta remember that corner. That's where my face is. I just poked myself in the face. Let's take another one. You have a hot air balloon. Because we all own a hot air balloon. It's tethered to the ground by a 75-foot cable. As the balloon is inflated, it begins to rise. Due to the wind, the angle of depression from the balloon to the ground is 52 degrees when the cable is pulled tight. How high above the ground is the balloon at the instant before the cable is released? I'd be depressed too if they're going to release the cable. I'm terrified of heights. So we have a hot air balloon, like the Wizard of Oz. Okay. Hot air balloon is tethered to a stake. My angle of depression, because remember I'm looking down, I'm sad. Because I'm up, so, well, I don't look sad in the picture, but I'm sad. My angle of depression is 52 degrees. Now you're supposed to say, Mr. Terwilliger, you just completely did that wrong. And I did, guys. I did to show you. Don't do that. Your angle of depression is this angle, guys. Hopefully I got that in time for you guys not to say, Mr. Terwilliger, I wrote in a pen. You don't do math in a pen. That's how you fix it. Okay. It's hooked by a 75-foot cable. How high is this crazy guy in this balloon? Okay. So we have an opposite, hypotenuse, and so we're going to use sine. So sine of 52 equals our opposite over our hypotenuse, hypotenuse, times both sides by 75. And according to my calculator, we get about 59 feet in the air. Okay? Got it? Good. Pause instead of page next. Simple harmonic motion. Okay? Basically what that means, a point on a line is moving if its distance, bop, 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 bop. Here's what you need to know, guys. This equation right here. What it basically means is there's things in the world that are represented by sine and cosine graphs, okay? Waves are a big one, right? In fact, all physics, all waves are calculated using sine and cosine curves. Or springs, because when you pull back a spring, it moves like this, right? So is the sine and cosine graph. In fact, you can make them shrink, just like when you pull a spring, it goes boing, 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 and it slows down. This you can make it so your sine and cosine start big and get smaller. Okay? We kind of skip that section. This is where we use frequency. Where instead of 2 pi divide by b for your period, you flip it around. Okay? I'm going to show you guys a quick video. I'm showing YouTube through YouTube, so I don't know how this goes. That's what it means. The spring's moving up and down. It's making the same curve as the sine or cosine, right? And that's if there's no gravity and there's no friction to get in its way. That's what they mean by harmonic oscillator. Okay? Physics! Okay. No sound, huh? Let's do it. Let's suppose we have something on a spring. It's going boing, 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 boing. And there's no elasticity, no friction, or air resistance. It's going to be displaced by a maximum of 4 centimeters. Find the modeling equation if it takes 3 seconds to complete one cycle. Okay, we assume. By the way, don't be mad. That equation's noteworthy. These examples are noteworthy. Angle of elevation, depression are noteworthy. Just draw a picture of them. Okay, guys, don't get lazy. Okay. Oop, wrong page. Assume we start at 0, 0. So that means we're going to have a sine graph, right? This maximum 4 tells me that's going to be my amplitude. Okay? Now, the fact that it takes 3 seconds to complete one cycle, that tells me that's my period. Okay? So I do my 2 pi over b equals 3. Okay? And when I solve, I get 2 pi over 3 equals b. Remember, you can just switch those around. So you do 4 sine of 2 pi over 3 x is our equation for that harmonic oscillator, and we're done. Enjoy!